So, I welcome all of you to this lecture. Today, I am introducing you to this concept of the line span, but before that I should discuss about your ship geometry. Now, here since most of you are already having some kind of naval architecture or I suppose this background, I suppose you are all familiar with some of the drawings that you might come across in ships. These drawings are normally kept next to the wheelhouse or in the wheelhouse itself, and the most important drawing, which of course gives what is the geometry of the ship, is your lines plan or the lines drawing. Now, before I describe what are the main aspects of this lines drawing and how one, of course, the detailing of these lines and how it is obtained is another course by itself altogether. So, that comes under the purview of what is called ship design, which of course all naval architects they must do. But here what we will be discussing is not the ship design in detail, that means how we go into this process of ship designing. But I will tell you that I have to cover a little some of the aspects of ship design, and that will tell you how this lines has come. Now, there are some aspects of this lines drawing which has to be kept in mind. You see, first of all, what happens, a ship has to perform certain tasks, and once the ship the contract has been signed. Actually, ship is not a product which is built in large numbers, so there are different parties who sign a contract, and based on that the design is formulated, and these parties they agree to what is called a certain design. So, this agreement has to come across, and what we normally say in naval architecture, that the owner specifies his specification, what is called the owner's specification. So, this is very important, that the ship has to perform certain tasks according to the specifications laid down by the owner. So, until and unless the ship now, until and unless the owner is satisfied, or after the ship has been built with the specifications as he has laid down, you see he may not accept the ship, or he may put some penalty clause and all that. So, what I want to tell you is that the lines drawing actually it comes from the ship design fundamentals, and from ship design, that is the owner's specification, the naval architect draws his own design. So, that is the beginning or the essence of the lines plan drawing. Now, in why in almost all the cases you will find that the previous history of the ship, that is what we call the a number of basic ship designs are referred to. So, these are very important. That means once the owner says that he wants say 26,000 tons of cargo to be transported from say Bombay to Dubai, or from Bombay to any other port. Now, the naval architect he looks up the data. Basically, this is basic ship designs, or basic ship designs is a set of data of similar ships that have already been built, and from that he lays down he tries to configure the parameters of length. Length is an important parameter. Then you have breadth, then depth. So, depth is D, and draft. Now, besides this you have another most important parameter, that is the horsepower of the ship or in the speed. So you will find another parameter which is the engine horsepower. Now this engine horsepower will give you the bhp of the main engine and also the speed of the ship, say speed in certain V's and knots. Now this is the basic fundamental work of the naval architect. He tries to configure all these are called principal parameters, especially your length, breadth, depth and draft. These are called principal parameters. Now what I want to tell you is that the lines drawing or the geometry of the shape, unless you know the principal parameters, you cannot draw the shape, isn't it? You must know what is the extent of the length or the extent of the breadth, the depth and draft, etc. All this has to be known. Now besides this, you will find, of course, normally the initial stages, uh, what is called, they do not specify what is called hull form parameters. Now I will explain hull form parameters in detail. Uh, Later on we will come across when we will do some certain calculations, but these are also very important. Say some of the hull form parameters are, say your block coefficient, that is CB, then you have the prismatic coefficient CP, then you have the midship area coefficient. So these are some of the hull form parameters. So the basic question lies that one has to decide on these aspects of length, breadth, depth and draft, the block coefficient, prismatic coefficient and midship area coefficient. So the naval architect, he tries to gather as much as data from his basic ship designs, and these basic ship designs should be very similar to the one that has been proposed, that is the owner by the owner's specification. It should not be far away. You see that the designer, I mean the owner specifies that he wants a 26,000 ton deadweight cargo ship, and you are looking for another, say, design of 10,000 ton deadweight cargo ship. That will be vastly out of place. That will not give the correct design. So what one has to do, one has to first gather all the data which will conform to certain ship build having more or less the same specifications. Now this data actually in shipyards, normally the shipyard data you will find that they have all this data of the ships that have already been built in the yard, isn't it? Otherwise they have to gather this data. Now so that is how the principal parameters are the first items that are normally fixed. Now once these principal parameters are fixed, now one has to give certain shape to this, what is called shape, isn't it? That principal parameters that you have come across, that is the length, breadth, depth, draft, you will simply draw them, it will be a box, isn't it? Of course, you have not imposed any hull form parameters, but first you start with the principal parameters. So now um, the lines actually is the most important drawing, is the most important, and it is the first drawing. See, now based on this lines drawing, the other drawings are made. So you have here, you have your lines drawing, then you have, say, normally we call this as a lines plan. So next drawing that will come out of this lines plan is your general arrangement drawing. So these two drawings are very, very important. One is the lines drawing, which tells you about the form of the ship, the extent of its principal particulars, the boundaries of the ship, and next the other drawing that is more important, that is more or less equally important, is the general arrangement, which tells you about the arrangement of the various cargo, the machinery, the passenger spaces, etc. inside the ship. So, uh, and of course, after this, the general arrangement drawing, you will have other drawings, that is your structural drawings. Of course, the structural drawings, they do not come from the general arrangement drawing, they can directly come from the lines plan. And these structural drawings, they are approved by the surveyor and they are given to the yard for fabrication of the ship. Now, all these drawings, they are related to this lines drawing. So, that is why I want to tell you that these lines plan is the most primary important drawing that one has to be very, very careful about when one either makes the lines drawing, because all the other drawings, they are emanating from this lines plan. Now, there are certain, of course, in naval architecture and shipbuilding, we have certain terms which normally you will find, as I explained the lines drawing. The lines, actually, they are is the most important drawing, I have already said, since it defines the exterior form of the ship's hull. Now, the main problem that we face is that the ship's hull is a curved surface. You will find that it is not a clearly defined or well defined object, just like your box or a round object. Now, this curved surface actually encloses a particular volume. Now, since most of you have already been in a ship, you will find that there is some, how you will describe whether a ship is good or a ship is bad, isn't it? Now, that is that description is given by the crew or the people on board the ship, isn't it? And this, suppose a badly designed ship which does not have adequate space or adequate circulation inside the ship, that is, there is lot of impediment to the movement of people, movement of cargo. You just come and collide with something and then suddenly there is a bulkhead, is a bad design. So, these two drawings, that is the lines plan and general arrangement, they are more or less go together. And so, what I want to tell you is that these lines encloses a particular volume of the ship. And you will find that nowadays ship designs have become very, very complex with the advent of the computer, and say a owner gives a particular specification, say owner specifies that the ship is to transport, say, 26,000 ton deadweight of cargo, right, say at a particular speed. He says that the ship is to cruise at a, say, speed of 15 knots. And then he also gives a certain range, either he specifies from one port of call to another, or he gives the range in nautical miles, say 6,000 nautical miles or 7,000 nautical miles, as the case may be. Now, the ship designer, he actually gives a number of options, isn't it? This is as far as the owner has specified, owner specification, but he can give a number of options. He says that, okay, you are giving 26,000 deadweight, you are proposing 26,000 deadweight at 15 knots, say that will at a certain price, say this will come, say, around, say, 30 crores or 40 crores, whatever it is. And he says that why don't you build, say, 25,000 ton deadweight at more or less the same speed, which will give you cost less, isn't it? Like that, he actually proposes a number of designs, 1, 2, there may be 3, with certain changes in the parameters. Say your principal parameters will change a little bit, speed will be reduced or speed will be higher, which all these design options, all these design options will conform to more or less the same specifications or nearly the same specifications. So, the owner, you see, after all, the owner, he wants the best product at the least price, isn't it? So, he sits down with the builder or the contractor, whoever may be, and he tries to, there is a discussion as to what should be the final design. So, nowadays actually what I want to say is that the parameters have to be changed, to give the best design. So it is just not one of a particular design. Nowadays you have to give, nowadays because of all so much detailing that has come into the ship design itself, that one has to be very particular as to what one is giving to the owner. In a competitive environment, you just can't, one just cannot get away with giving some kind of a substandard thing. So the so all the time the shipbuilder or the contractor, he has to prove that he is more knowledgeable than the owner. Owner may be less knowledgeable. Owner may be a ship owner. He is a businessman. He is always working in terms of money. But the shipbuilder or the contractor, he has a group of naval architects and other engineers who constantly updates the design. That means he proposes at the beginning itself, he will propose a number of variations in the design with variations in the principal particulars, etc., such that the owner himself gets the best product. Now, so he makes a study of the previously built ships, as I have already told you, that is the principal parameters. And you see, there are certain limitations in the shipyard itself. Owner may propose, say, a certain form of the ship or a certain particular design, but you may find, but the contractor or the shipbuilder, there are certain limitations in the shipyard. So you have, for fabrication of, for hull fabrication, this is called hull fabrication, the shipyard may be facing certain limitations. So hull fabrication is basically done in the hull shop, and you will find that the shipyard has to be, the shipbuilding manager, he has to be satisfied with the design. Shipyard hull, this is shipyard, what is called hull shop fabrication is done by the shipyard, yeah. So shipyard limitations, you write shipyard limitations. So here actually the designer, the naval architect has to, who has been employed, or the designer who has been employed by the shipyard itself, he should know what is the shipyard limitations. Now shipyard limitations may be in the nature of, say, the extent of your dry dock, extent or size of building berth, or dry dock. So whatever size that the owner proposes has to fit inside his building dock, isn't it? Otherwise, or sometimes you will find two ships are being built in the same dock. They have a partition, isn't it? You make a bulkhead sort of partition in the dock itself, and you can build two such ships. So whatever this, that the ship itself should be buildable. Ship, that is the proposed ship, should be buildable or fabricable. In naval architecture, we say that it is buildable. That means the shipyard should not face any problems in fabrication. So there are two important stages one has to keep in mind, is that after the design, normally the naval architect takes care of that, the fabrication and erection process. Fabrication and erection. So whatever form that is proposed in the lines plan, ultimately that has to be built, isn't it, into something which is going to sail in the water. And the who is going to build, that is the shipyard. So shipyard limitations are very important as to the size of the vessel that is to be built, and other parameters may be there. So the some of the other that is your building berth size I have already mentioned. There may be another limitation on what is called craneage. your crane capacity. So that means ship is, you will find ship is say a huge bulk carrier. The steel weight etc. will weigh, we say around say 7,000 tons of steel. Steel fabrication has to go on, and normally you will find that the ship is built in what is called weldments or certain blocks. Nowadays you make block assembly. So that has to be lifted by cranes or has to be moved or transported from one shop to another. So here actually the craneage stroke transportation capacity has to be kept in mind. So this ultimately will lead to what is called block assembly. So now actually in the present practice in the ship design and the ship fabrication has become very automated with the help of what is called computers. Then you have automatic machines, robots, automatic welding machines, etc. It is very automated, and normally you will find that the lines plan that normally we do by hand, that is now being replaced by a booklet where all the information regarding all the ship geometry is there. So here this is another important aspect before the naval architect actually goes to making a line, is that he should remember the size of the building berth, the extent of craneage that is applicable, because later on he will be doing what is called the, he will have to break up the structural parts that is used to make these blocks, and that should be given to the hull shop to be fabricated. So the most important point that ease of fabrication and erection has to be kept in mind. Remember that shipbuilding actually consumes a lot of time, ease of fabrication and erection, and not only that, the shipyard has to employ labor for doing this. So the larger amount of time the ship takes in say hull shop fabrication, the more the cost will go up. So actually the Japanese yard, they have perfected this fabrication and erection to a large extent by automation. Normally they build all these large tankers, there's VLCCs and ULCCs in just few months time, whereas in our yard we are just not even able to build a 26,000 ton bulk carrier in 1 year. So that is the state of affairs, and you will find that the shipbuilding industry is largely an assembly industry. The shipbuilding, why actually I am a little bit straying from the point of lines drawing, but all this is comes into the picture, shipbuilding industry in is largely what is called assembly industry. Now how efficiently we do this assembly will be reflected in the quality of ships that are produced and also the cost. So different shipyards, they have their different capacity, shipyard capacity. So I have explained all this capacity for doing this work. So the owner, he inquires about all this before he gives the contract, isn't it? First he specified that I have told you about the owner's specification. I have already talked about, is that he will give certain speed, cargo, weight of cargo to be transported, so weight of cargo, speed, etc. But an intelligent owner will also inquire about the capability of the shipyard itself to build the ship. You give a certain ship to a contractor, say he gives at a pretty low price, nowadays in the competitive market, he bargains and says that okay, I will give you at half the price, and that contractor is given. But ultimately you will get a, I have seen all this happen, that the ship is not being, or half the ship has been built at the end of the, and the contract has to be cancelled. And the shipyard, the contractor has also gone bankrupt, he also cannot pay up. So normally, so one has to satisfy, the owner has to satisfy himself that the yard has the capacity, has the quality to build a ship at a certain specific time. If he is not satisfied, all this is built into the contract. He does not, even if the contractual price of the ship is found to be very low, he should not go into that kind of contract. You see, otherwise he will lose a lot of money. So shipyard capacity has to be clearly configured. And next is your coming back to this hull form. So this hull form you will find that I have written is largely related to this buildable quality. You see. So here I have outlined is that this basic necessary shape should have no difficulty in being constructed in the hull shop of a shipyard. So hence ease of fabrication should always be kept in mind when the lines drawing is prepared. So different in Hindustan shipyard, I think a couple of say 20 or 30 years, they experimented with what is called the pioneer class ships, where you will find that the hull actually consisted of a number of plates, I mean straight plates, not bent. Actually the curvature of the hull, so the hull curvature actually takes a lot of time. That is, you have to bend the plate, you have to shape the frames. So people, they try to do away with this and try to form these straight sections, but I don't know, but eventually it didn't work. So actually the shape of the ship, one has to, the naval architect has to design at what shape the ship is going to be built. So your lines drawing is nothing but shape definition. Now you will find that the ship does not have a well-defined shape by any mathematical form or mathematical equation. Ship shape does not conform to a single mathematical definition. So that is, it is neither a full, that is a box type of design, nor a cylinder. So it is something which is a mixture of certain specific shapes, and of course these shapes vary around the length, breadth, depth, etc. Now when the lines is being defined, this shape definitions also has to be kept in mind. And there are other parameters which are also more important. First is, I have talked about the ease of fabrication related to your shipyard capacity. The shape should be well defined in that particular volume. And the other parameters that are more or equally important is that if you build a cargo ship, sorry, excuse me, the lines drawing actually tells you or talks about the internal volume. This internal volume is very, very important. Why? Suppose internal volume, you can split up this volume into a number of parts. First you have, now if it is a cargo ship, then this is cargo volume, right? Then the ship has your machinery. It has to house basically cargo, machinery. Then you have your crew or passengers. They have to be housed properly. Sorry. Then the other items of deadweight, that will come. I'll explain what is meant by deadweight and lightweight. You have fuel oil, you have your diesel oil, your lube oil. So all this has to be carried in a certain volume. This volume is most important. So before the ship is designed, one has to calculate this internal volume. That means from the owner's specification, the cargo, that means there is a definite what is called cargo is given in terms of stowage factor. This cargo volume we can calculate from a stowage factor, which tells you the amount of volume occupied by a specific weight of cargo. So that is called a stowage factor. So from that, the naval architect or the designer, he calculates the cargo volume. And from the initial design which he has gathered from your basic ship, he knows what are the machinery which are likely to go on board the ship. And from that, he can calculate the machinery, that is your main engine volume, your auxiliary engine will be there, your generator. This normally will come from the basic ship. Of course, fuel oil and lube oil, once he knows the engine horsepower, he can calculate this, and he can calculate the tankage. And there will also be freshwater tankage, freshwater volume, which is being consumed by the crew. So all this has to be housed, that is the internal volume. The lines drawing will give you this internal volume, and internal volume should give sufficient space for accommodating all these items. So one has to be the naval architect or the designer, he has to be very, very careful that he does not miss any item of volume which cannot be accommodated in the ship. Normally one finds that when a ship is slender, normally we call it a slender ship. Now actually slender ship, that is a very thin ship, will give you large amount of speed. Say this is a slender ship rather than a full form vessel. A full form vessel will, say, a tanker. A tanker is normally a block coefficient is around 0.8 or 0.85. So this is a full form vessel, and that will give you, this gives say 20 knots speed. This will obviously give you something around say 15 knots. Now, so what we find is that you have to make certain compromises in the design itself. You cannot just go on increasing the volume. Normally your crew and passengers will be very happy if they have more and more space, isn't it? But you will find if you make the ship much more voluminous and much more bulkier, then it will consume more and more power because of the resistance. The ship will be encountering more and more resistance when it is propelling in the sea. So it has to consume more and more power, and the fuel bill of the captain will go skyrocketing. So here actually one has to strike a compromise between a slender form ship and the full form ship. Normally you will find that the tankers, they go at a very slow speed. Tanker speed we say will be around say 12 knots, 13 knots, like that. So that, and invariably you will find that the volume of a tanker is quite large. That is, rather it is box shaped. Tanker, you will find they have a large parallel body. Only at the ends there is some fairing or some narrow portion that is there to break the waves. So tanker, it is a slow speed ship carrying large amount of volume, whereas you will find in container ships the block coefficient will be pretty less, maybe around say 0.6 or 0.665, and container ships will cruise say around 22 knots, 30 knots. So high speed ships. So you will find you have to strike a compromise between ship speed, that is engine power, ship speed, and the internal volume. So here you will find that the ship design process, of which line span is a part of the ship design process and is a very crucial component of the ship design process, goes through a number of iterations. That means these volumes, the once the contract has been finalized, the naval architect tries to play around with this volume. That means he passes the ship design process through what is called a design spiral. Actually, all this is covered in ship design. I am not going into much detail, but just for your information sake, you will find normally in what we do, we pass all these parameters, that is the initial parameters which we have collected from your past data of basic ships, through a spiral, and we try to optimize this design. So this is called design spiral. Because I am not a very good expert in drawing freehand sketches, so it passes through a number of turns and spokes at which some calculations are made. So this is called a design spiral. Remember, at this stage, the preliminary design stage, the principal parameters have not yet been fixed. So here you start from the owner's, so this owner's specification. So here this will be owner's specification somewhere here, and you try to vary the parameters, and at the spokes you will find at this junction you do certain calculations. The first calculation will be your hydrostatics, which of course another teacher will tell you. Next will be, say, resistance and propulsion. So next may be your structural, your ship strength. So all these calculations are made by varying your initial parameters governing the line span, that is your length, breadth, depth, draft. And of course, there is a constant check on all this, that it conforms to the classification society rules, that you see a ship that is being built, it has to, here you write the from the owner's specification it comes to the final design. So the line span particulars or your parameters, they constantly go on changing at these stages. Of course, this is comes under a separate study called ship design, which I am just giving an inkling how it is being done. So till he comes to this final design. Final design, that means at the final design stage, he has all the parameters fixed, and there the engine horsepower, your propeller diameter, everything is fixed. So after this, after the final design has been made, then you go on drawing the line span. So final design being made, then lines drawing is so lines drawing will only come after the design has been finalized, and before that there is no point doing the lines, because it is the design spiral is passing through a number of iterations. That means the naval architect is not sure what best and offer he can give to the ship owner. So these lines, that is your final lines that has been made, will definitely satisfy your owner's requirement with all the optimized values. So nowadays you have programs related to hydrostatics, RMP, ship strength, there are programs. So now it is easier if you give the initial values, you can get the final values of your hull form parameters of length, breadth, depth, draft, block coefficient, speed, power, etc. All these are calculated in various programs till you arrive at the final design. And this final design, after the final design has been made, then one goes into this lines drawing. So at this stage, actually, the conditions, the criteria of stability, speed, etc. Then you have buoyancy. All these are naval architectural calculations. The main is your speed, stability, buoyancy, and of course strength. They have been satisfied. But in the design spiral program, the initial or what is called your preliminary design, if you want to start, we normally call it preliminary design. Preliminary design, that means from the preliminary design you are coming to the final design, and you have at the final design stage, that means all these criteria of stability, speed, buoyancy, strength have been satisfied. So now you go to this, what is called, that is the preliminary design stage is over, and now one can draw the lines. So here lines, of course, the lines drawing, then one can, before going into this detail of lines plan. So this is the genesis of the lines plan drawing and how it comes from the ship design, encompassing all the shipyard capacities and etc. Now here in the we come to the basic drawing itself. So what we have fixed the extreme boundaries of the ship, that is your length has been fixed, your breadth, all this has been fixed, then your depth, draft, but with this, only these parameters, one will not be able to draw the ship. With such a scanty information, you cannot draw the ship because of the changes in curvature of the hull. There are certain definite changes. So normally what we say that when one draws the lines plan, you take help of what is called the offset table. I will come back to this later on. Now this offset table gives you the beds at a certain height above the baseline and also at different stations along the ship. Now this offset table is used for making the lines drawing. Now if you have any questions, you can ask, just to clarify certain points, because I have already lectured for say another 45 minutes. So till now I think everything is clear, or if you want to know anything, then you can ask. So this is, what I was talking is that the lines drawing is the basic drawing, and when one wants to make a lines drawing, he has to remember a lot of things. The ship designer or the naval architect has to be very careful when one makes this lines drawing, because all your other drawings are based on the lines drawing. So any mistake in the lines drawing is going to play havoc in the final shape of the ship, and that will be, suppose your lines drawing is not giving any perfect breadth, or it is not what is called smooth or uniform, then your ship will not be able to be propelled at that speed, will not give that speed, or it will not give the maneuvering characteristics. Maneuvering is another important parameter which is very much dependent on the hull form characteristics. So these maneuvering characteristics also depend, which of course I have not said in your earlier, greatly depend on hull form, greatly depend on hull form. This is called hull form characteristics, the lines. Now all this thing has to be analyzed in that design spiral itself. So you can see that the lines drawing itself is of tremendous importance. That is the basic drawing, which will govern not only your capacity to carry the cargo at a certain speed and stability, having certain amount of reserve buoyancy. Normally in ships we have this design draft. Most of you are familiar. What is this design draft? That is the maximum draft at which, or maximum immersion at which the ship is to float. That is, the ship should not sink. And if this draft criteria is not satisfied, and if the ship, I mean, steams at a greater draft, then there is some penalty. And this draft is calculated based on what is called your load line. This design draft is called a load line. So the captain of the ship has to be very careful that the ship is not going to be immersed at a draft greater than the maximum prescribed draft at the load line. So load line draft normally one sees in a ship, you will find at the midship region there is this load line mark. Previously this was called the plimsoll mark. You will find a line like this, and there are certain marks on the right hand side, and your classification is LR. So that is this mark actually, this is the summer load water line, okay, this one, the horizontal mark. So the other marks are there for different seasons in the year at certain locations around the globe. So winter, North Atlantic, etc. So these load line mark comes under the purview of what is called International Load Line Conference. So these people, that is the captains and the ship those who are owning the ship, they normally interact, and they come to certain agreement on this draft mark. Actually, the maximum immersion of the ship, which is given by the draft mark, is decided upon at this conference, and then it becomes a rule. So if you are loading the ship, you should not load the ship beyond this mark, otherwise the ship is in danger. So actually the essence of this mark you will find is that the immersion of the ship will be at a certain draft, and beyond the draft you will find a certain gap is there. That is, this gap is not weighted by water. So that is called a freeboard. So this International Load Line Conference actually gives you the amount of freeboard. And freeboard is also important from another point of view. You will find that the freeboard specifies the amount of reserve of buoyancy. That is, the ship is having so much of reserve in the buoyancy against sinkage. So unless you have this freeboard, then the ship is in danger of sinking. So that is, before you go into this lines plan, the draft has to be defined from the load line conference. Load line conference actually specifies, you will find from the tables, they give you certain freeboard tables. where according to the length of the ship, say this is your length of ship, the extent of that F, that is the freeboard, is specified. So these are given, say ship length, it starts from I think 24 meters, and this is given in millimeters. So exact, if you consult your the freeboard tables, you will find. Right, huh? Charmit for it.